So now if this is your Kubernetes setup, so first of all, as we discussed in the above checklist, this checklist, you know what, each and everything, every single feature facility is offered by Kubernetes, right? So whatever expectations were there in the above list, every single thing is offered by Kubernetes. Now the point is how Kubernetes is going to achieve all these functionalities for you, right? Because you know what, you need to understand entire thing in very much detail, then you can think about Kubernetes in reality. Okay, so what I need to do, I need to redesign that architecture. So this is my Kubernetes master machine, and let's say this is my minion 1 and minion 2, minion 1 and minion 2, and they all are connected, I'm assuming that. Okay, Docker engine is running everywhere. So now what we need to do is we need to understand how Kubernetes is managing all this. Okay, so entire Kubernetes is a collection of so many products. You know what, so the most important component in Kubernetes master node is we have Kube API server, right? Kube API server. That means the achievement or the list of achievement that we had above, how Kubernetes will achieve that. So it's not about master and worker minion only. Kubernetes nodes has so many components, so those components are responsible for maintaining and achieving those things that we are expecting as of now. So you know what, the most important and most amazing component in the master node only is Kube API server. Now in a very much descriptive way, you have to understand what exactly Kube API server is. So let's say if this is administrator or this is a developer, fine. So either you are an administrator or developer. How any of the client or developer can access to Kubernetes cluster? So I'm calling it, this entire setup, as a Kubernetes cluster. Okay, so how you and me can connect to Kubernetes cluster? It's very much same way like from our own laptop, how we were connected to Docker engine that was running on top of EC2. So the answer was we are connecting to Docker engine by TCP socket. I hope you remember that fact. So we have exported that variable called export docker host and something docker host, then we connecting to Docker engine and we are maintaining it. So we don't need to get access of it, we can connect it by TCP socket. If you did remember that, just say yes in the chat window, because it is very important to relate the technology that we have learned earlier, right? So say yes, okay, hi, hello, whatever you want, feel like. Okay, wonderful. For Sonu, it's yes, you remember that. So the way we were connecting to remote Docker engine was this, right? Okay, great. So I was expecting the same. Now likewise here we have TCP socket. So to access your Kubernetes cluster, we can connect to Kubernetes API server. So Kubernetes API Server. So any user or developer, they can connect to Kube API Server. So that is kind of endpoint. So endpoint means where either you and me can connect to Kube API Server for any further communication. So let's say if I have a Docker image and I want to deploy it in Kubernetes cluster, so I can never go in Minion node and deploy container. I just need to connect to Kube API Server and ask that yes, I want to deploy this. So if you want to delete any container, you want to do anything regarding deployment or management or something, the only point of contact for you is Kube API Server, right? And this Kube API Server is running on master node only. Fine. So the Kube API Server is running on the master node only, nothing else. I mean, except master node, it is not running anywhere, right? So I hope you all are understanding that the use of Kube API Server. Why my laptop battery is dead, right? So hopefully you are understanding it. So are you able to hear me? Because I can feel in my mobile phone the streaming is not up. You can hear me? Yes or no? Okay, great. So I think you screen is frozen, okay, but you are able to see that. Okay, so now Kube API Server is very much okay as of now. The next one is another component in Kubernetes. We call it Kube Scheduler. That means if as a developer or as administrator I requested for my Kube API Server that yes, I really want to deploy my Docker image in Kubernetes cluster itself, so which will be received by Kube API Server, but how Kubernetes master will decide out of the list of Minion nodes where exactly this container will be deployed. So first of all, you have to understand very well that Kubernetes master will never deploy your container in its own node. So here your container will not be deployed, it is just a management node. So in any of the Minion, either Minion 1 or Minion 2, this will be deployed, right? So either in Minion 1 or Minion 2 or whatever minions you have, this will be deployed. So now out of the list of minions, which minion will be the one where your container will be deployed? So this decision will be taken care by Kube Scheduler, right? So Kube Scheduler is that component, right? So that you can use to schedule any of the application in any worker node like this or this. Thank you so much Tendulkar for reminding me. Charger kharab ho gaya. I cannot help myself in this quarantine, right? But chal raha hai, theek hai. Okay, so you are understanding Kube Scheduler. So Kube Scheduler will do something like that. It will find the right worker node or Minion node, then it will deploy container here. Okay, so that means the use of kube scheduler must be very much understood. So this kube scheduler will take the responsibility of selecting the right minion node for you, and then it will schedule container in any of the minion node. So that is the use of kube scheduler as of now. Okay, but how kube scheduler will understand which minion is healthy, which minion is very much okay, and it's, you know, healthy means it has enough resources. So we have another component in master node, we are calling it node controller, right? Okay, so now node controller is the one that will take the responsibility to check the health of minion nodes. That means, is this minion is very much healthy, it has enough resources, or maybe you want to add a new minion on the real time, right? It was a new minion in the real time, so it can add a new minion in the, you know, Kubernetes cluster. And if something you want to disconnect, so you want to put it down for some reason, let's say for maintenance, for backup purpose, you want to remove that node, so this responsibility will also be taken care by node controller. Okay, so if you are understanding all these components as of now, just say yes in the chat window. Okay, so all these components, then say yes in the chat window so that we can go ahead. Yes, Rhythm, I'll be coming to that point, but no worries. So I think my laptop battery is connecting and disconnecting in the charging mode. Right? Fine. So very much, so you all are understanding it very well, so it's fine as of now, right? Likewise, we have kube scheduler, we have node controller, we have few more controllers here. So let's say those controllers I'll be talking about later on, but let me introduce one more. And the next component in Kubernetes master is replication controller. Replication controller. Okay, what is replication controller in reality? Replication controller is something in Kubernetes master that will make sure number of container availability in the worker node. That means this is the very important component. That means, let's say as an engineer you use Docker image to deploy 2 containers, and these containers are randomly distributed here and there by using kube scheduler. So let's say container 1 is running here, container 2 is running here. Now by any chance this manager or minion node 3 goes down. If the minion node 3 goes down, this container will be down. So what replication controller will do, because in the beginning time you decided to have 2 containers for this Docker image, So this replication controller will connect with kube scheduler, and it will plan the container somewhere else in any of the minion node those are healthy. So that means it will connect to any of the minion node like this or this, and then it will check and use it. So simply this replication controller is responsible for maintaining the container count. So anytime if you have lack of containers or one container goes down, how the container will be created automatically. So you don't have to do that, it will create automatically. Okay, so automatic container creation will be happening in that case, right? So I think replication controller is also very much useful, and it must be understood to you as well, that yes, you are understanding it well, the role of replication controller here. Okay, so yes, so this is the very important component where it will maintain the count of container, right? Yes, no, yes, no. So these are few components. So just say yes in the chat window. Okay, okay, okay. Please do remember all those things, because these are very important for tomorrow discussion, but as of now we are having all this. Okay, wonderful. So 4 things are running. See, so by combining these names, let's say we have in master node we have API server, we have kube scheduler, we have a node controller, we have replication controller, right? So these components, they are running here. So by combining them in single entity, we are calling it control plane, right? Control plane. So that means these all are control plane component. So rather than calling them individually by their name, we can also call them, this Kubernetes master has components, and these components we call it control plane component. That means here we are going to call them control plane components, and these are running in the master node. Okay, so you can call them control plane component, or you can call them on the master node, or whatever you want, but control plane component is an official keyword by Kubernetes. Okay, so control plane component is very important thing. I think you can remember that. Okay, now so, but there is a problem. The problem is how Kubernetes master node will remember how many containers, how many applications, and how many nodes are running and down in the Kubernetes cluster. So that means how Kubernetes will remember the status of Kubernetes cluster or application. So what does that mean? Let's say we have one master, 3 minions or 2 minions Out of 2 million, this minion is almost full 50%. This minion is only 30% consumed, and this is only 10% got consumed. In minion 3 we have 10,000 containers running. In minion 1 we have these many containers running. Out of these many containers, how many are healthy and which website is up and down, and if one minion goes down, how it will be migrated to here. So that means whatever going on in the running Kubernetes cluster, this information needs to be stored persistently, right? Because if somebody is rebooting all the machines, all the information must be stored persistently. Okay, so in the Kubernetes master itself, there is a database server, and we call it HCD. So this is one of the most popular and powerful and fast database server, and where every single status of Kubernetes cluster, either cluster status or application status, let's say how many cluster we have, how many master and minion we have, which is healthy, not healthy, how much RAM, CPU, every single thing consumption and will be stored by etcd. So it's a pure NoSQL database that store data in a key value pair, right? And that etcd is also running on the master node. Okay, so the status of cluster or application will be stored in etcd database. So this is the next component in the master node. Okay, so and this is the most important component. I can see the brain of Kubernetes, because every memory, every information will be stored in etcd, right? So are you understanding the brain of Kubernetes cluster etcd? It's a pure NoSQL database like Redis, and it will store information in key value pair, so that whatever things are going on in the Kubernetes, it will be persistently stored here, right? If this is also very much cool for you, then say yes or okay or cool in the chat window.